Garbage collection explained. Beginner level. Introduction. When programs run, they create objects, variables, and data structures that use computer memory. However, once some data is no longer needed, the memory used by that data should be freed so the system can reuse it. If unused memory is not released, the program may slowly consume more memory and eventually crash. To solve this problem, many programming languages use a system called garbage collection. Garbage collection helps programs automatically clean up unused memory. This concept is widely used in languages such as Python, Java, JavaScript, Go, C#. What is garbage collection? Garbage collection is the process of automatically detecting and removing objects that are no longer needed in memory. In simple words, garbage collection equals automatic cleanup of unused memory. Instead of developers manually freeing memory, the programming language runtime handles it automatically. Why garbage collection is important? Garbage collection helps programs checkmark free unused memory automatically. Checkmark prevent memory leaks. Checkmark improve program stability. Checkmark simplify programming. Without garbage collection, developers must manually track and free memory, which can be complex and error-prone. How garbage collection works. Garbage collection works by identifying objects that are no longer referenced by the program. Example process. A program creates objects in memory. Some objects are used temporarily. The program stops referencing certain objects. The garbage collector detects these unused objects. The memory used by those objects is freed. This process allows memory to be reused by new objects. Example in Python. Example. Data equals 1, 2, 3. Data equals none. Explanation. A list object is created in memory. The variable data references the list. When data is set to none, the reference is removed. The list object becomes unused. The garbage collector can remove it from memory. Reference counting. One common technique used in garbage collection is reference counting. Each object keeps track of how many references point to it. Example. A equals 1, 2, 3. B equals a. Explanation. The list object now has two references. A, B. Reference count equals 2. If we remove one reference, A equals none, reference count becomes 1. If we remove the last reference, B equals none, reference count becomes 0. So the object can be deleted from memory. Cyclic references. Sometimes objects reference each other. Example. Class node. Def __ init __ self. Self.ref equals none. A equals node. B equals node. A.ref equals B. B.ref equals a. Here, A references B. B references a. Even if both objects are unused, the reference count may not reach 0. To solve this problem, modern garbage collectors use cycle detection algorithms. Manual garbage collection in Python. Python usually runs garbage collection automatically. However, developers can also trigger it manually. Example. Import gc collect. This forces Python to run the garbage collector immediately. Real-life analogy. Think of garbage collection like cleaning a workspace. While working, you accumulate papers, tools, notes. After finishing, anything no longer needed should be removed to keep the workspace clean. Similarly, garbage collection removes unused objects from memory. Advantages of garbage collection. Checkmark automatically frees unused memory. Checkmark reduces risk of memory leaks. Checkmark simplifies programming. Checkmark improves program reliability. Checkmark helps manage large applications. Because of these advantages, garbage collection is widely used in modern programming languages. Disadvantages. Crossmark garbage collection may cause occasional pauses in program execution. Crossmark less control over memory compared to manual memory management. Crossmark slight performance overhead. Despite these limitations, garbage collection greatly simplifies memory management. Where garbage collection is used. Garbage collection is used in many programming environments. Python runtime, Java virtual machine, JVM, JavaScript engines, Go runtime, .NET runtime. These systems automatically manage memory while applications run. Simple definition. Garbage collection. The automatic process of identifying and freeing memory used by objects that are no longer needed by a program. Final summary. Garbage collection helps programs manage memory automatically. It works by checkmark detecting unused objects, checkmark removing them from memory, checkmark freeing memory for new objects. Without garbage collection, programs may suffer from memory leaks and instability. With garbage collection, programs become more reliable and easier to develop.